Hello and welcome everyone. Thanks for joining and tuning in. My name is Victor and I'm a developer advocate at ClearML. In this session, my goal is to essentially show you how easy it can be to run ClearML at scale and starting there with very basic experiment tracking and then building up from there. You'll see exactly what we're going to do and everything will be in the web UI, the ClearML web UI, as well as the code editor. So no slides here. We'll get right to the good stuff. Okay, so let me first set the scene a little bit. What we want to do in the session is create a sarcasm detector. It's just for fun, but essentially what I want to show you is how to deploy or how to train a transformer at scale. That's the end goal here. And so how to do that, we first have to actually train a transformer. And to have a use case there, we chose for the sarcasm detector. So this is just a fun little toy project, but should be applicable to most of your other projects as well. Don't mind the code too much. I'll jump around here relatively quickly. It's just to give you an idea on how it might look like in your own workflow. So let's get started. The first thing that I want to show you is the sklearn version. So we also will do the transformer in just a second. But let's start with the sklearn because it's relatively easy and simple to give an overview, and then we can go to transformer in just a second. So imagine you want to make a sarcasm detector. What would you want to do? First, of course, have a baseline model. In this case, let's make linear regression work. So we make a sklearn trainer class here. And what you can see here is we just make it, give it a subset of size 1000, which essentially means we're only going to use the 1000 first records of our data set because it makes it a little easier to deal with, but obviously you want this as the full size in the end product. And then we're going to call train. So what this actually does, let's go very quickly around this, is it will actually start a task using ClearML. A task in ClearML is essentially an experiment, and it will track everything your code that goes into your code and also comes out of your code. That's the idea. So in this case, we want to give it a project name of sarcasm detector and a task name of sklearn training. We set some parameters. You can do this with a dictionary. You can do this like this as well. And then we set some other parameters for the actual code. This is relatively simple. Then we create the pipeline. A pipeline for a sarcasm detector might look like something like this. For example, a TF-IDF vectorizer, which essentially takes your sentence, turns it into a vector, and then that vector can be used to train machine learning model on, which in this case is linear regression, which is obviously badly named because it's a classifier. We have our config here, which is essentially just the config parameters for this linear regression model. And then we just connect it. And using task.connect is very much the same as here. We set the parameters, right? We'll see in just a second why that is extra cool in ClearML. But for now, let's just take into account that this saves all of your config parameters. Right, and then we actually take the model, have it as logistic regression, and then create a pipeline that first vectorizes the input sentence and then runs the model on it. So let's collapse this and collapse this so that we can actually see. Now, we also want to get our data. Our data in this case is going to be a data set from ClearML data, which is a data set versioning tool. You can use it in conjunction with the experiment manager, but you can use anything that you want. It's all open source. It's all in good faith. So you can do what you want there. Now, we also get a local copy of that data set, and that data set will just contain a lot of sentences with their class if it's sarcasm or not, or sarcastically meant or not. We get a local copy of that, load it into Hugging Face, do a train test split, check if there is a subset or not, and take it. And then we just train the model. This is relatively simple. So let me run this first. And this is what your normal overview or like your normal workflow would look like, right? This is just getting the data, pre-processing it, and training it. When you run it, the first thing you'll see is that it'll create a new task in ClearML. And if we actually go to ClearML and refresh the page here, this is the ClearML web UI with the project overview. What you'll see here is all of your projects. You can also go to the experiment manager right here. And you'll see that there is one task running. What this does is what you would expect from any experiment manager. So you can see here that it's running. The execution tab has all of the necessary information to do cool stuff. So you have the source code, if uncommitted changes, install packages, configuration, like we just did. So that is, for example, general, which is the different options that we connected in the code, right? Where was it? Right there. I can't find it, but you saw it before. There we go. So C, number of jobs, etc., etc. So these are all here. Artifacts, which is the saved model. As you can see, it's currently completed. So we can actually download the saved model. It's just a joblib file that we just saved from before. We can also go to info. Console logs our saved scalars. In this case, a linear classifier or linear regression classifier doesn't actually have a training routine. So you can't actually see a plot, but you can see the actual output. And we also have one plot, which is essentially the confusion matrix. So all of that is to say there is an experiment manager in there. Let's go to the train transformer now, because that's what we want to do. Here we have pretty much the same thing, right? We have the get data, we get a local copy, we load it in to train test split, very much the same thing. We have the tokenizing of the data, which essentially does the TF-IDF, but then in a different way for transformers, obviously. Then we compute our metrics, which we will also use to plot the confusion matrix and get our accuracy. And then we can use the task, the ClearML task, to actually log, for example, the accuracy in very much the same way as we did here for sklearn. And then we have the training routine as well. But this time, for example, not only can we add parameters as with the add parameter prompt, as well as connecting a dictionary, we can also use training arguments from Hugging Face right there to connect it this way. There is an integration in Hugging Face that you don't even have to log all of the parameters, all of the scalars. They will all be added automatically because of the code that we wrote in Hugging Face. Right, if I run this will take a lot longer. So I am going to go back to the ClearML overview right now and go from a task that is already running or that has already finished running, but you'll see the progress as we go along. So you can see here the Stillbird training. It has all of the execution and configuration stuff that you would expect, or at least not yet. The data is still being pre-processed, so stuff is coming in as the code is being run. Artifacts, of course, we have the import model, but the output model is not yet been trained. Now, if we go and take a look at here, this is where it actually filled in. So this is a task that was completed. We see all of our output models, optimizers, schedulers, stuff like that. We can see the console output, and this time we can actually see the scalars. If we take a model here that was trained for much longer, we can, for example, see the loss going down like this. So this is really cool stuff. But we are here to talk about AI at scale. So how can we scale this up, right? Well, the first thing we have to do is get one of these things running on a remote machine. And the cool thing that ClearML allows you to do is basically take any of these trained or like already executed the Stillbird trainings or transformer trainings, just like the one we have already running. We can actually right-click on it and clone it. And if we clone it, now we have a draft mode of this existing experiment. And what we can do now is we can edit stuff. We can just say, okay, I want to edit, for example, instead of this commit, use another commit. But in commits and in uncommitted changes and install packages, that might not be very interesting. What is very interesting is, for example, in the configuration tab. So now I can say I edit this, and let's change this to something weird. So in production, obviously, you would want to change your hyperparameters. Here, to just prove the point, I want to change the seed. So the seed, let's change that to 13 and 12, or like 12 and 12, for example. Save it. And that's it. There is actually not much more to it to change your parameters on the fly. And because it has all of this execution information already in there, what we can do now is right-click the task that we cloned, and that is now draft mode, and then queue it. And this is where it starts to scale up, right? Because now we can actually put this task in, for example, our GPU queue, and it is currently pending. Now, if we go to our workers and queues here, which is an extra tab in the ClearML web UI of basically one of the tools in the ClearML tool stack, we will see that there is a number of queues here that you can use. So for example, I've set up the CPU queue, GPU queue, default, and services. You can create any new queue that you want. If you go into the GPU queue, you'll see that the next experiment is the experiment that we just made. If there were more in the queue, you could change their priority right here. You could drag them up and down. Very, very nice. But what we'll also see is that there are currently no workers assigned to this queue. So what are workers? Now, this is where the scale comes in. So we want to set up multiple workers to start working on all of the experiments in this queue, right? You could do that with a CLI command, but what is much more interesting is to use autoscalers, which is another tool in the tool belt of ClearML. If you go to the applications right here, you'll see that we have an AWS autoscaler, a ClearML GPU compute, and a GCP autoscaler. An Azure one is on the way. Any of these autoscalers do pretty much the same thing. So let's go to the ClearML compute. And what you'll see here is that there is currently 0 workers on our running autoscaler. Now, this autoscaler is connected to Genesis Cloud, our partner, and it basically is a service that keeps running in the background and looks at the queue that you specify it to look at. And once there is a task in that queue, it will spin up a VM, it will run everything that is necessary to make it into a worker, and then it will assign itself to that queue to start working on the services or like on the jobs that we've been talking about. Now, in just a few moments, this autoscaler should be able to detect that there is actually a task in the queue, and it should start working on that remotely, which is super, super cool. Now, if we go into the configuration here and see what it looks like while it's spinning everything up, you can see that in this case, we have a GPU type, the number of GPUs, the amount of vCPUs, et cetera, basically your machine specification. You set this up once, right? This is a background process that checks this queue. Very important, of course, is the monitored queue. So which of the queues are we going to look at to spawn these machines? And in this case, it's the GPU queue. So we have the cloud machine limit of 3. You can basically scale this infinitely on AWS or GCP, depending on how much you want to pay about it, over it. But essentially, you're building your cluster as you go, which is super cool. Then you have an idle time, which essentially says, okay, how long will this worker be running without any task to work on before it's shut back down again? Any task that comes within this 5 minutes will have the worker already waiting for it, and that will be much, much faster. Then you have Docker images that you can set yourself, obviously, to run everything in. I won't click on my Git configuration because this has my personal access token in it. But basically, it says it allows the worker to go to GitHub or GitLab or Bitbucket and ask for the code. Now, as we can see here, one worker has been set up as of this moment. So what if we go now to our workers and queues, we can see that there is an extra available worker next to the worker that is used for the actual background process of the autoscaler. We can now see that there is one worker that is currently running our clone of this Tilburg training. If we click on this, we go back to our experiment overview right here, and we can actually follow along live while it's setting up its packages, while it's running everything, and see how well it's going. So you can even, if I go to my projects here and see it when compared to the other stuff, you can see, for example, clone the Tilburg training and select these two. You can compare. You can have multiple scalers. At this moment, it's not training. It's still installing packages, but you can still have the hyperparameters compared, have the scalers compared when they come in, which is super, super cool. Now, there's one last thing that I want to check or that I want to show you before I end this is how can we go even bigger, right? Because now we have essentially what is a 3-click cluster that you can just have auto scale depending on the amount of stuff that you want to run at the same time. But what if we want to automate even that, right? So we just cloned an experiment and changed its hyperparameters and then run it on a remote machine. And those hyperparameters will now be injected into the original code for that machine to run. So we can automate this process. We can go to Hyperparameter Optimization in the Applications tab. If you go there, we can actually see that I've already run this because this will take quite a little while, but I can show you how it's set up in just a sec. So if we go to configuration here, what we essentially need is the initial task to optimize. Now, if you go back here to your original task, let's go to the sarcasm detector right here. If you go back to this original task, let's say you've run this Tilburg training and you want to use this one, you would copy this ID and then paste it right here. What that will essentially do is this application will automatically clone this exact task infinitely many times, however you want, and then it will override parameters. And then you also have to set it a queue. So the parameters to optimize, forget the queue for just a second. So the parameters to optimize, for example, are learning rate and weight decay in this case, they correspond to these parameters. So learning rate should be here somewhere. Learning rate, there we go. And then the weight decay as well. You can basically say, I want the minimum value to be this, the maximum value to be this, and the step size to be this. Set it up, then set it up to be in a queue, and it will just spawn new tasks in that queue that, remember, will be taken care of by the autoscaler completely automatically. And then you can give it a job title, an experiment to work in, etc., etc. And if you click go or update or launch in the case of a new one, what you will see is this. So you can actually see the optimization metrics. In this case, that would be, oh, sorry, I actually didn't show you this. If you want to go into the optimization configuration, you'll see that there are several options. I can't click them open right now because it's an existing task. You'll have several options here on how to optimize, for example, random optimization, or in this case, hyperband optimization. And you can also say, I want the accuracy, the eval accuracy, to be as high as possible. And what we then see is this maximum optimization metric. Let me just zoom in on this for a little bit. You'll see it climb up every single time. And this other line basically says, what was the last task that was reported? Here you can see an overview of all the different experiments that were run. You can even see throughout all of these experiments that were run on this huge cluster, you can actually see what their scores were. So if we select, for example, these, we see that a lot of these good tasks that end up very high in the accuracy eval will actually be on the lower side of the learning rate, which is very, very interesting. Same thing, but with the general weight decay, that it should be probably pretty high as well. So these combinations generally tend to lead to a high accuracy. You have the same idea here with a summary of all of your experiments that you can just go through. Also a resources overview, just to make sure that everything is assigned correctly. Right, so this whole thing was trained on multiple workers with just a few clicks when you just started with this one piece of code that then connected its arguments. And in this exact line, they can be overwritten by changing the parameters in the UI. So when you cloned this, you can actually change the parameters here, and they will be injected right there. So that's the very neat trick that I wanted to show you. This is how you can start scaling up with ClearML. Now, the cool thing about HPO, for example, is that it doesn't actually have a limit on what it can optimize. It doesn't really care what is inside. So you can just override any parameter, even from your data processing pipelines, for example. And it just runs on this army of agents that you can either set up yourself or more easily use the autoscaler to do all of the work for you. So as you just saw with all of the explanations in close to 20 minutes, I just gave you a full overview of everything you'll need to get started training your models on hundreds of agents if you really wanted to. So I hope you found this interesting. Thank you so much for watching. And if you have questions, I'll be in the chat. So please ask them there. And thank you for watching.